This is our last section of chapter 3. We still have to solve our system with 3 variables. So go ahead and solve that out for x, y, and z, either using substitution or elimination. And when you solve the system out, you should get 6, 0, negative 2. Again, this is the last section for chapter 3, 3.6, solving systems using matrices. A matrix is a rectangular array of numbers written within brackets. So our matrix is represented with brackets like this, and we'll have numbers on the inside. And each number in a matrix is called a matrix element. So number 3 is a matrix element. And row operations is what we do to solve a matrix. So again, we already talked about matrix. Our dimensions are rows by columns. So if we look at our matrix down here, we have one row here and another row here. Remember, rows are horizontal, columns are vertical. So if I ask for the dimensions of matrix A, you would say 2 by 3, since we have 2 rows by 3 columns. And for matrices to be equal, their dimensions have to be the same, and every element in corresponding positions must be the same. So looking at our matrix here, we have to identify the element A, 2, 3. Okay, so again, when we represent dimensions, we talk about rows by columns. So we first look at row 2, and then go over to element 3, so we'll be 8. Do the same thing, 1, 3, go to row 1, column 3, and our element is 17. So when we represent a system with a matrix, each matrix row represents an equation. The last matrix column shows the constants to the right of the equal sign, and other columns show the coefficients of one of the variables. So if we were to represent this as a matrix, our system of equations, we would draw our matrix box. We draw a line down partway through our matrix to represent our equal to sign. And again, we only write the coefficients. So row 1 will be our first equation. So our coefficient for x is 1. Our coefficient for y is 3. And then we put our constant term on the other side of the equal to sign. Then we go to our second equation. Again, only write the coefficients. So we have 3, 1, and negative 8. Again, if we were asked, this first column is our x's, our next column is our y's, and our last column are our constant terms. So go ahead and write these write these systems as matrices. So hopefully you wrote the first system right across and the second one right below it. So our first matrix is a 2 by 3 and our second matrix is a 3 by 4. Notice how we don't have an element for y, so we have to put a 0. In this one we'd have to solve it, so we have variables on one side, numbers on the other. Next, what if they gave us a matrix and we have to represent that as a system? So, again, you take your first column, and that's our first equation. Again, our first column is x, second column is y, and the last number is the constant term. So we put 5x plus 2y, and that line, remember, is equal to, so we put equals 7. And our second one, notice how we have 0x, we don't have to write our x term. We have 1, y, and that equals 9. And do the same thing for the second one. You should have 2x equals 6, and 5x minus 2y equals 1. Okay, next, our row operations. Again, we use matrices in order to solve our matrix, or to solve our systems. The row operations we can do is we can switch any two rows, multiply a row by a constant, or add a row to another row. So the combination of multiplying and adding is basically what we do the most. So the goal of our row operations is to get this matrix here if we have x and y only. We need to have a column of 1s and everything else is 0s. Or if we have 3 variables, x, y, and z, we need to still have our diagonal of 1s and everything else be 0s. And when we solve this out, whatever number we get here for a will be what x is equal to, and whatever number here for b would be what y is equal to. And again, if we have 3 terms, c equals z. So our first step when solving out our systems, we first have to write it as a matrix. So we have to represent this with just the numbers. And we have 2, 5, and 4 is 1. And again, I like to keep myself organized. So if you already noticed, we have a 1 in our top right corner. So that's good because we need to have that there. But we need to get a 1 here, a 0 here, and a 0 here. So in order to keep ourselves organized, I always like to draw arrows so we know what our new matrix is going to be. So I can already draw my next matrix. We already know it's still going to stay the same dimensions, 2 by 3. And what I would do is multiply row 1 by negative 2 and add that to row 2. So I would write 2 row 1, and we add that to row 2. Since we're adding to row 2, our row 1 will stay the same. So we have 1, 4, and negative 1. That stays the same. But to fill in row 2, we need to do a couple row operations. So 1 times negative 2 is negative 2. Plus 2, we get 0. Same thing for our next term. 4 times negative 2 is negative 8. Plus 5, we get negative 3. And last but not least, negative 1 times negative 2 is 2. Plus 4, and we get 6. Next, we need to get this to be 1. So I would multiply row 2 by negative 1/3, because I saw that 3 and 6 are factors of each other. We don't really like to use fractions, but we can. So again, we only did operations to row 2, so we can rewrite row 1, 1, 4, and negative 1. 0 times negative 1/3 is 0. Negative 3 times negative 1/3 is 1. And 6 times negative 1/3 is negative 2. So we have completed row 2 because we needed a 0 and a 1. But we still need to get our top row to be 1, 0. So we need to multiply row 2 by negative 4 and add that to row 1. So again, we're not doing anything different to row 2, so that stays the same. So we'll have 0, 1, and negative 2. Then we multiply row 2 by negative 4, so 0 times negative 4 is 0, plus 1. 1 times negative 4 is negative 4, plus 4, and we get 0. And negative 2 times negative 4 is 8, plus a negative 1, we get 7. So notice how we have the diagonals of 1, and other term is 0 on the left-hand side of our line. So our solution should be an ordered pair is 7, negative 2. Go ahead and do the same thing. We're going to have a couple different steps. Remember, write your system as a matrix first. Do a couple row operations. And remember, you need to get to this point here. Since we only have 2 variables, we need to have 1s in our columns. Everything else is 0s. And whatever number we get here will be what our x is equal to. And whatever number we get here will be our y. So once you get there, our solutions will be 1, 2. I'm ready to work on this in class.